There are a lot of high schools out there right now that are coming up with an interesting model where they've got a medical academy where they're really targeting their offerings to help students prepare for medical careers. And I was talking with a teacher from one of these schools, and they said, our school's medical academy requires 4 years of life science and 1 year of chemistry. Do we really need to add physics and earth science to do this all standards for all students thing? And I should note that this came from an anonymous teacher, not from one of these schools whose logos I stole off the web. Well, this is an interesting question. I'm not sure where this should go, because obviously these are well thought out, well-intentioned programs, and doing them well is sort of at odds with the all standards, all students message of the NGSS in California. So I started looking into this a little bit, trying to think, well, medical training does require students to take and master physics courses. We don't want them going into college afraid of physics because they've never seen it before. So we want to definitely avoid that. But interestingly, pouring through just a couple of different research documents, the research usually seems to point to chemistry as the college class that deters pre-meds. And take a look at this quote. Largely because of negative experiences with chemistry classes, underrepresented minority students and women show a disproportionate decline in interest in continuing pre-medical studies. So if we're really going to target our interests, it's true that perhaps physics and earth and space science are not the places to put the effort if we're really trying to prepare the medical careers. But I did get to thinking about this. Is there some way that we can make everything work out that actually does accommodate some of the NGSS standards in physical science and earth and space science and prepare students to be better at their medical careers? I decided to sketch out a course that I'm calling Biophysics and Environmental Health, which is an NGSS course for medical academies. And it's really designed to target the physical science and earth and space science performance expectations that have applications to real-world phenomena in the medical sciences. And the top section of here is involving physics content, and the bottom involving earth science content. Students begin the first instructional segment evaluating information about the risk of concussions in sports. First of all, they have to learn what a concussion is, and then they look at some statistics to see if different sports are riskier than others. The main goal here, though, is to get them to understand about collisions and Newton's laws. They use mathematical models to determine if players of different sizes face different risks, and then they engineer helmets to reduce forces during a collision. The next instructional segment instills an understanding of the electromagnetic spectrum by looking at phenomena from medical imaging. Students begin by looking at the advantages of digital X-rays and compared to the old-style photographic plates in terms of both their safety and their usefulness. That helps them understand what's going on during an X-ray, how the energy is traveling into and being absorbed by different parts of your body, which allows you to start talking about safety and developing protocols for reducing exposures to X-ray. We also want them to understand a little bit more complicated medical imaging, including radioactive tracers, which allows students to develop models of the interior structure of the atom and radioactive decay. We also give them the chance to look at CAT scans, CT scans, and see how they work as a tomography method, where they're looking at how waves travel different speeds in different types of materials in your body. Now, this is really similar to the way that we look at Earth's interior and figure out what's going on in there. And so along the way, we take a slight diversion to look at tomography of the Earth. The next instructional segment involves an understanding of medical devices, including things like artificial heart valves that use principles of electromagnetism, and also the pacemakers. You've probably seen signs that say that people with pacemakers should be careful around certain magnetic fields and microwaves. And so why is that? Well, they're going to have to understand a little bit about the intersection between electricity and magnetism, and also understand what these devices do inside your body. So it's a wonderful marriage of both the health concepts and the physical science concepts. The course then takes a turn towards environmental health issues, which requires an understanding of some of the earth science core ideas. This instructional segment has students looking at a phenomenon in California where mercury from old gold mines contaminated sediments upstream that since then washed into our oceans and contaminated our fish. In order to understand what's going on, we want to look at a whole model of erosion and the water cycle that shows how these things interact, And once we have that, we can actually apply it to a similar but slightly more complicated problem of organic farming and tracking the flow of fertilizers and pesticides used on crops, and having an interesting debate about whether organic farming is worthwhile or not. A lot of the earth science performance expectations deal with our energy resources and how we get our energy. And it turns out that how we get our energy also has substantial implications for our health. And what we have students doing is we have them analyzing the healthcare costs of air pollution, and also looking at, there's some wonderful maps, particularly for Southern California, that show cancer rate and how it varies in different communities based upon their proximity to industry or transportation. And so students are going to actually be looking at this data in depth and be making public service announcements that advocate for solutions to polluting behaviors. Many of the energy resources that cause air pollution are also linked to global climate change. So in this instructional segment, students are going to start off understanding the causes of climate change. Then they're going to look at the implications for health of that by using simulations to predict how a warming climate will affect the spread of diseases like malaria. This scenario allows students to use really rich geoscience data sets to tackle some important health problems from around the world. Overall, this course provides an authentic and relevant exposure to some of the most important core ideas in physics and earth and space science. It does leave a lot of the performance expectations on the cutting room floor, but I think it represents an important compromise for people like anonymous medical academy teacher who really want to prepare a meaningful experience targeted towards these very important medical careers for their students. So, leave me a comment if you think this is going to be a useful direction for you to go.